In this section, we'll be adding a wall jump mechanic to our character controller. Wall jumping is possibly my favorite game mechanic when it comes to a character controller. When I think back on some of my favorite games like Super Mario 64, the character control is just so good, and a part of that is wall jumping. Mario is able to slide down a wall, jump off of it, jump between walls that are tight together, and it really just gives a lot of power to the player. It makes you feel like you're in charge and that you can explore the game world how you would like to. You're able to jump up walls and get to places that are hidden and find secrets. And sometimes players are even able to go to places in the game world that the developer did not intend them to be able to do, and that's a lot of fun. So with our wall jump mechanic, when the player is sliding down the wall and he's holding towards the wall and does a wall jump, we want the player to momentarily boost out from the wall, but then pull back in towards it and do a little bit of a wall climb. And then when the player holds away from the wall that he's sliding against and jumps, we'll just simply push the player out from the wall. And if we have two walls that are close to each other and the player does a wall jump, we want it to gracefully handle wall jumping back and forth between these two walls. Make sure it feels good for the player. So we now have the information that we need, and the main information was we needed to know if the player is currently wall sliding. We now know that, so we can get started implementing our wall jump mechanic. Our player is going to have both a regular jump and then also a wall jump. So we need to modify our jump code just a bit to take into consideration whether the player is doing a traditional jump or if he should be doing a wall jump. Let's go ahead and open up our character controller 2D script. And let's go down to our section where we handle our jumping. So inside of handle player input, right now we just have our traditional jump. And now we need to modify this a bit. We now have information of when the player is wall sliding. So let's make some room here. And we're going to add a new conditional here. So we know that the player pushed the jump button, and now we need to make the decision, should this be a standard jump or are they wall sliding, therefore they should do a wall jump. So we will say if is wall sliding, and then we'll simply say else. And I'm going to cut and move this standard jump code inside of this else statement. I'm going to add a comment. So this is our standard jump. And then up here we have our wall jump. Okay. So now we have that determined of when we should be doing a wall jump and when we should be doing a standard jump. So now we're ready to actually implement some code that will perform the mechanics side of our wall jump. But there is one issue that we need to take care of first. The problem is when we do a wall jump, we're going to want to jump away from the wall. And currently we don't know which side of our player is touching a wall. If you remember, let me open this back up here. You'll see that our player just has the one hitbox for wall checker, this one box collider 2D. It can detect if we're touching a wall, but we don't know if we're touching a wall on the left side of the player or the right side. So this is an issue that we'll explore in the next video. In the previous video, I pointed out the issue that with our wall checker, we have a single box collider 2D here, and so we're able to understand if the player is touching a wall, but we don't know if it's on the player's left side or if he's touching the wall on his right side. So there's different approaches to solving this problem, but the one that I want to do is pretty simple and straightforward. What I want to do is we'll take our wall checker game object and we'll modify it a bit, and then we'll duplicate it so we have a wall checker dedicated for our left side and then a separate one for our right side. So let's select our wall checker game object underneath the player and come over to the box collider 2D component, and we're going to modify the size so that it's 0.25 on X, and then we're going to give it an offset on X of negative 0.5. So you'll see it just sticks out of the left side just right there. And we'll change the name to be left wall checker. Okay, and now let's just duplicate this. I do Control D, Command D on Mac, and let's change this one to be named right wall checker. And of course, on this one, we want to give it a positive offset of 0.5. So now we have our left and our right, and you can see that they're separate and they're in the correct positioning. Okay, so that's perfect. Now we need to go back to our scripts. So let's open up our character controller 2D script, scroll up to the top, and we have a new player state that we need to keep track of, and that is the wall direction. So which direction is the wall that they are touching, or the last time that they touched it. So I'm going to make a new, under player state, a new public int, and we'll call it wall_dir for wall direction. And save our script here. Now let's go ahead and we're going to move over to our wall checker script because we need to make a small modification here. First thing that we're going to do is add a new public integer, again, that we'll call wall_dir. And with this integer, we're going to set it as either a 1 or a -1. 1 for the right side of the player, -1 for the left. And then now all we need to do is on our trigger enter 2D, all we need to do is reference our character controller again and dot wall_dir. We'll set it equal to wall_dir. Okay, and let's go ahead and save. And while we're at it, just to make this consistent, on our onTrigger exit 2D, let's go ahead and we'll set character controller dot wall_dir equal to 0. So that way when we've left the wall, then we'll set it to 0. So I think that kind of makes the feature more complete to know that we're not touching a wall, even though we do have the is touching wall state already. So let's now save our script. So this way, our wall checker script will update our character controller's wall_dir state to let him know if he's touching a right-facing wall for a +1 or a left-facing for -1. So let's go, we've saved our scripts, let's go back to Unity. And the last thing that we need to do, let's select left wall checker for now. And we want to, this is important, we need to make sure that we set wall_dir equal to -1 for our left wall checker. And then on the right wall checker, of course, we need to set it to +1. So that's what our character state will be updated to when the collision happens for this wall checker. So go ahead and select your player game object, and then let's play the scene. And you'll probably need to scroll down in the inspector, but you now see that we have this wall_dir, and it's 0 currently. But now as we move and touch a right-facing wall, you see that our wall_dir is 1, and this wall is -1. So it is working correctly. We now have the information to know if we're touching a wall on our right side of the player or on the left side of the player. Perfect. So, all right, now we get to actually implement more of the actual mechanic of jumping away from the wall. So we'll go ahead and get started on that in the next video. Alright, it's time to get back into coding and actually add some logic so that our player gets pushed away from the wall when he wants to perform a wall jump. So let's open up our character controller 2D script, and towards the top in our public variables area, I'm going to add a little space here and add a new header for our wall jump. And underneath that, we need to declare a few variables that will determine how our wall jump behaves. So let's do a public float, and we'll call the first one wall jump acceleration x. And now we need one for the y-axis as well, so we'll do public float wall jump acceleration y. And then I want to add one more, public float current wall jump magnitude. And we'll talk about this variable in just a bit here. But let's scroll down in our character controller here, and we have this empty space here where we are ready to start to write our logic for our wall jump. Now, first thing I want to do, just like we've done with other mechanics, for example the standard jump, we're just setting a velocity here. So we declared our x and y wall jump velocity variables. So let's try that for now. We'll do rb.velocity equals new vector 2. And we have our wall jump acceleration x and wall jump acceleration y. Okay. Now let's go ahead and save. Let's go back to Unity and give this a try. And of course, we'll need to give a value to our wall jump acceleration x and y here because they are 0 and 0. Let's give it a value of 16 on x and 16 on y. Now let's go ahead and play and try our wall jump and see what happens. Okay, so you'll see currently I just shoot up the wall when I wall jump. Let me make this game view a little bit bigger. So it's behaving correctly in that it's allowing me to jump on the wall, and my jumps aren't limited like they are in the air where I only have 2. So that's working, but it's not much of a wall jump. It's like a wall scoot right now. So let's go ahead and stop there and go back to our script. Now, if we look at this, we're setting our velocity here. We're setting our velocity to the wall jump acceleration x and wall jump acceleration y. So if you think about this though, this code gets executed. We jump. We decide I'm wall sliding, so they're doing a wall jump. Let's add some velocity. Then the code falls through, passes by this else if, and now we hit rb.velocity where it gets set again. And here we do our traditional code that deals with just moving and dashing. So what's happening is we're setting the x velocity here, but then down here we're setting the x velocity again, and so it's just overriding our wall jump acceleration x there. You will notice though that our wall jump acceleration y here does end up playing out, because down here we're just saying rb.velocity.y. So maintain any current y velocity that you have at this point. I don't care about it. So that's working out fine for our acceleration on y for our wall jump. Okay, so now onto that extra variable that I added. Basically, we want to keep track of our current wall jump magnitude on x so that we can then add it down here and not have it be overwritten. So here's what we're going to do. I'm going to add a comment and say track our current wall jump magnitude. So we'll say current wall jump magnitude equals wall jump acceleration x, x. Okay. And now this way, let's go ahead and on the x here, it doesn't really matter because it's getting overwritten, but I'm just going to put rb.velocity.x. I'm going to copy this here. Now down here, outside of these parentheses, we want to add this onto the tail here of the x value that's being calculated. So we'll say plus current wall jump magnitude. So that way this math will be calculated, but then we'll be able to add this value to the end, and it won't be overridden, and it will actually play out. Okay, let's go ahead and save our script. Let's play our scene. Let's go jump off this wall here. Whoa, okay. It's still not working. What else do you think is wrong here? Okay, let's look at our code again. Now, if you think about it, we're trying to jump away from a right-facing wall, and if you recall, in our wall checker script, we are setting a right-facing wall as +1. So when I go to jump away from the wall, it's going to set our x velocity to +16. But positive is to the right, and we're against the wall, so it's not going to jump us away from the wall like we want. So So there's a bit more that we need to do here, and it's also part of the reason that we have this current wall jump magnitude variable. Because you could just copy our wall jump acceleration x, paste it down here, but there's a little more math that we need to be doing here. So if you think about it, we can use our wall direction variable, wall_dir, and so we're going to multiply our wall jump acceleration x by wall_dir, and this is the wall that we're currently touching. So for example, against that right wall it's +1, but we want to jump away from it, so we need to multiply that by -1. So that will give us the correct direction to push us away from the wall. Okay, so let's go ahead. Oh, and I wanted to add one more comment here just to be complete. So we're tracking our current wall jump magnitude and apply our wall jump y acceleration. Okay, save our script. Let's go back to our Unity and play the scene again. Okay, let's try jumping against that wall again. Okay, now that time it did actually push me correctly away from the wall like I wanted, but if you're testing this along with me, you'll notice that you can no longer move. And that is because we have permanently set the x velocity with that wall jump, and it's just constantly pushing the player off to the left. So there's one more big problem to solve for our wall jump, and that is that we need that x velocity that we're adding to push the player away from the wall. We need that to decay over time. We can't just have it always be there, otherwise we lost control like that and it just pushed us away and we couldn't move our player any longer. So in the next video, we're going to talk more about that issue, and we're going to actually write the code to add a nice smooth decay to our wall jump that will kind of complete it and round it out. Currently, when we do a wall jump, it's pushing the player away from the wall with an acceleration on x and y, but we don't have a way to tone down that velocity over time and give control back to the player. So we're going to add some code so that it decays that value smoothly over time, so it makes the wall jump still feel good and it makes it functional as well. So let's go back to our character controller script, and we need to add one more variable underneath our wall jump. Let's make a public float, and we're going to call this one wall jump decay magnitude. So this variable will affect how quickly the velocities from our wall jump decay over time. Okay, we're going to scroll down to the bottom of the script now and actually make a brand new method. And we're going to call this, we'll make it private and call it decay forces. So, and what's cool is with this method here, what we're going to write right now is specifically for our wall jump, but you could do this, use this method for any kind of mechanic in your game that involves adding velocity that you want to slowly decay over time. So let's get started. And we're just going to write some conditional statements and then add and subtract our current wall jump magnitude by our wall jump decay magnitude. So we're going to say if current wall jump magnitude is greater than 0.0, so if it's positive, then we want to decay it by subtracting. So we'll say current wall jump magnitude minus equals, we'll add some brackets here, and we'll say time dot delta time multiplied by our decay magnitude, wall jump decay magnitude. So every frame this is going to be run, and we're going to subtract from our current wall jump magnitude, and that will slowly over time decay it and bring the velocity back down to 0. And we want to add an extra check here just to be safe. We'll say if current wall jump magnitude is less than 0.0, then we want to simply set it equal to 0. So, and that's just a extra check that I like to do, because we're subtracting this value here. We're trying to go from positive down to 0, but if we overshoot and subtract by too much so that we're negative, then we just want to make sure that we've zeroed out that value. Now we just need to do the same for the other direction. Else if current wall jump magnitude is less than 0.0, now we want to add to it because we have a negative force that we want to neutralize back to 0, so we need to add to it. Current wall jump magnitude plus equals time dot delta time multiplied again by our decay, wall jump decay magnitude. And then we'll add that check just like we did before. If current wall jump magnitude is greater than 0 this time, then we want to zero it out. Equals 0.0. Okay. Sorry if I went through that too fast or typed too quickly. Give you a little bit of time here to catch up, or feel free to pause the video. But that is basically what we want for that method. So now we need it to be run every frame, and the place that we can do that is inside of our update method. So let's scroll on up here to our update, and underneath get player input, we now want to call decay forces. Perfect. So let's save our script, return to Unity. Okay, so now let's select our player, scroll down, and we need to make sure we have our values set correctly here. So I have a few values that as I've played around with, these have felt good to me. So I'm going to change wall jump acceleration X to 22 and Y to 15. And then on our wall jump decay, let's set that to be 60. Alright, let's go ahead and play our scene and see how these values work for us. Very nice. Perfect. So you'll now notice we apply our X and Y wall jump velocities, but now that we've implemented that decay magnitude, it doesn't launch us away from the wall and we don't lose control. It decays smoothly over a period of time, and that gives our wall jump a nice arc as you hold in towards it and jump. Very nice, that feels great. And you'll notice as well that you can jump away from the wall, and you get an extra boost as well if you do a wall jump off of it, rather than just jumping normally. Nice. Perfect. So that wraps up our wall jump mechanic, and that's actually all of our core mechanics. We have them all implemented with our character here. So in the next section though, we get to add some visual flair that really will tie everything together. It adds a lot of depth, adding some animation and character. So now that we have a controller that controls well, it feels well, we can add some nice visual flair. And of course, feel free to play around, move the terrain around, make some obstacles for you to jump around on. And now you have all of these variables in your inspector here that you can change at runtime and get your character controller playing just how you want it to. So you have all the tools available to you now. You have a complete character controller with some really great mechanics. So I'll leave it at that, and let's move on.
Double kill.
In this section, we will be adding some cool animations to our character controller. So we have a mouse character that was designed just for this course, and we have some really cool animations that match each of the game mechanics that we implemented. So what I have is I have a downloadable Unity package that I've put together so that I've already handled setting up the animations inside of Unity and slicing up the sprite sheets. And so I wanted to do that because this course doesn't focus on animation. Instead, it focuses on the game mechanics. So this way you can just import this package and then you'll be ready to go. And then we will just be writing the code to trigger the animations to happen for each game mechanic. So you should be able to see a downloadable file for this course, and it is called Character Controller 2D-Animation. So once you've downloaded that, a Unity package can be opened just by double-clicking it, or you can drag it into your Unity project view here. So I'll just go ahead and double-click it, and it will show you all the files that it wants to import. So let's click Import. Okay. So now if you look at your project view here, you'll now see that you have a player animation folder that has a whole bunch of files inside. And like I said, these are files that I have pre-built for you guys to make things easier. So underneath, we have a animations folder, and that has the actual animation clips for each animation. Underneath sprites, there are these sprite sheets for each of the game mechanics that the mouse does. So we've got a double jump, an idle, a jump, run, and wall slide. And then there's this player animator prefab, and this is the visual side of things. We have a game object that has a sprite renderer and an animator. So then we're going to take this player animator game object, and we want it to be nested as a child of our player game object that's already in the scene. So let's expand this if it's not already. And then we're just going to click and drag player animator underneath player, and it'll be added as a child. Okay, so now you can see that we do see our mouse character, but it's hidden by this capsule collider here. And actually, it's a mesh renderer. So let's select our player root game object, and you'll notice that it has a mesh renderer component. So we're just going to go ahead and uncheck that box. So we don't care about the mesh renderer, we don't want to see it. So now you'll see that we can fully see our mouse character now. And if you look at the scene view, we still have our capsule collider, that's still there. We have our wall checker colliders, everything's still there. We've just added a new game object that focuses purely on the visual side of things. So it will show our mouse character and it will play back animations. Okay, so let's go ahead and play the scene and see what happens here. Nice. Okay, so you'll see that I can still do everything that I could before. I can do all my game mechanics, but you'll notice that the mouse is just doing his one idle animation and it's just looping. And that's because we haven't told it yet when it should do the different animations, and it just defaults to an idle animation. Okay, go ahead and stop playing. Now, one thing that I want to do quickly is I want to make our player game object a prefab. And so if you haven't yet, you may have already done this. Underneath assets, make a folder for prefabs, and then you can just click and drag player underneath the prefabs folder, and that makes a new player prefab. And then what I want to do now is inside of this player animation folder that we imported, there's a animation demo level. Let's go ahead and open that, and you can save this demo scene that we're currently in. Okay, and this is just a scene that I threw together that's a little bit bigger so that you can have more room to jump around and experiment with your character controller. So this scene is empty though, it doesn't have our player, and that's why we made this player prefab just a moment ago. So now we can click and drag our player prefab into the scene, and you'll see he appears right there. And then one other thing that I need you to check real quickly. Sometimes exporting a Unity package can be wonky, and if you click on the terrain game object, you'll see that it has a layer, a physics layer of player, which is obviously incorrect. So just select all of these terrain game objects and change their physics layer to terrain. There we go. And then let's go ahead and save our scene. Okay, and let's play once more. All right. So, and just like in the previous scene, it's working the same. We can do our wall jumps, our double jumps, everything's working. Just our animation isn't implemented quite yet. But this was the setup work that we needed to do. And then next we'll actually write the code which triggers the different animations to happen when the different game mechanics are happening. So let's go ahead and move on. We're now ready to start writing some code so that our mouse character will change animations depending on which game mechanic is being performed. So open up your script editor for our character controller 2D script. And then what we're going to do first is we're going to make a new section here in underneath public, and this will be a header that we will call animation. And underneath animation, we are going to have a public reference to a sprite renderer for our player renderer. So we'll say public sprite renderer. That's the type, and we'll call it player renderer. And underneath that, we'll make a public animator that we will call player animator. Now, the next thing that we need to do is we need to keep track of which state the player is in. Is the player running? Is he idle? Is he jumping? Is he wall sliding? So there's all these different player states that we want to keep track of so that we can easily change the animation that we're showing. So what I suggest we do is we'll make a new enum of player state. So we'll say enum player state. And you do open and closing curly brackets. And then we'll list out all the different states that we'll have. So we're going to have an idle, a run, a jump, a double jump, a fall, a wall slide, and a wall jump. There we go. And then we need, let's see, we need a new private variable that is of type player state, which is the enum that we just made, and we'll call it current player state. Okay. And then we want to initialize the player state when the game first runs. So inside of start, just make room underneath, and we will set current player state equal to player state dot idle. So that makes sense. By default, our player is just going to be idling when the game starts. Okay. And now let's scroll down a bit to our update. And we're already checking for player input. We are decaying forces, and we're going to add one new method that we're going to call handle player animation. So each frame this will be called, and then it will determine what animation should be played for the player with the current player state. So let's go ahead and scroll down underneath decay forces, and we'll make a new method that is called exactly what we added up above, handle player animation. Okay. And then what we're going to do is we are going to type up a kind of big if-else-if statement for each of our different player states. So let's add a comment first. We'll say set appropriate animation trigger depending on current player state. So what we'll do is we will say if current player state equals player state dot idle, then we now reference our player animator, and on a player animator there is a set trigger method, and that's what we will be using to tell the animator to change animations to playback. So we'll say dot set trigger, and we'll pass a string, and these are strings that I have predefined inside of our animation controller. So for player idle, we'll do player idle, and I name it with a capital P and a capital I. So capitals on the first of each word. Okay, and then I'm going to go ahead and just start typing out the rest of these, and you guys can pause the video if you want and just type them up yourself. but it's all about the same, so I won't be explaining much more here. We're just going through each game mechanic and checking, is the player state equal to this state? If it is, then we want to set a trigger on the animator so it plays back the correct animation. So let's go ahead and type out the rest of these. Now that we have our giant list of if statements typed out, we will now be able to set the current player's state, and then it will go ahead and set the appropriate trigger on our player animator and play back the correct animation. So this video is running a bit long, so we're going to go ahead and cut it off here. And in the next video, we will start to write the code that sets our current player's state for each game mechanic. We're now ready to write the code that will be setting our current player state appropriately depending on the input from the player. So let's scroll up and let's first go to our handle player input method. So you'll remember that's being called just about every frame. And what you'll notice as we write this code specifically is that the way that we've written our character controller will make this really easy for us to determine what the current player state should be, as far as if they should be running or should be idle or jumping. So let's go ahead and get started. Underneath our movement section here, let's make some room. And the first one that we're going to add is for player run. So we're going to add a comment and say, do we have a moving force on X and are touching the ground? So that's our criteria to determine if the player is in a running state. So we'll say if mathf.abs force to apply.x is greater than 0.0f and is grounded, then we will set player state for running. Current player state equals player state dot run. So this mathf.abs, we're just checking the absolute value of force to apply, which we determine that right up above. If the player has input negative or positive on the x-axis, then we know that the player is going to be running left or right. So we can check that there is some input, make sure that they are touching the ground, and then we can assume that the player should be in a running state. Then if they aren't running, we can check if the player's idle. So let's add a comment and say, are we stationary on X and touching the ground? So we'll say else if force to apply dot x equals 0.0f because we're stationary or idle and we are touching the ground, then we can set player state for idle. Current player state equals player state dot idle. So again, you'll notice that this is really easy to do because we already have all the information that we need to make these decisions about what the current player state is. So let's continue on. The next one that we're going to look at doing is our wall slide. So we have wall slide right here, and inside of this if conditional, underneath is wall sliding equals true. Let's make a bit of room. And this one's pretty simple. If is wall sliding is true, then we know that our player state should be wall slide. So we'll just say set player state for wall slide. Current player state equals player state dot wall slide. Okay, and then inside this else statement, if we're not wall sliding, then we set is wall sliding equal to false. That's fine. But make some room underneath that, and we want to add another conditional where we're going to say if rb dot velocity, so if the rigid body velocity dot y is less than 0, so same thing as up here, if we have a negative y velocity, so we're falling, then we can set player state for fall. So we can say current player state equals player state dot fall. Okay, perfect. Now let's keep going down, and the next one that we're going to do is the wall jump. So again, pretty straightforward. If the player is wall sliding, they've pushed the jump button, we know that they're going to do a wall jump. So underneath this existing code inside of the is wall sliding if conditional, we'll add a new comment for set player state for wall jump. And we'll say current player state equals player state dot wall jump. Okay, and then this next one is for our normal jump, and it's going to be a tad trickier. What we will do is inside this existing conditional, let's go ahead and go underneath where we increment current jump count. And the only reason that this is a bit different is that for our animations, I have a animation for the standard jump, and then I have a different animation for the double jump where the mouse curls up in a ball. It's pretty cool. So we need to determine, is this the first jump or is this a double jump? And again, we've done a good job writing our character controller, so this is super easy for us to determine if this is a first jump or a double jump. So let's write just a comment here and say, is this a double jump? And how can we determine that? We have current jump count right here. It's that simple. So we can say if current jump count is greater than 1, then we are doing at least a double jump. So we can say set player state for double jump and say current player state equals player state dot double jump. Okay. And if current jump count is not greater than 1, it's going to be 1, so it will be our first jump. So we'll say or the first jump. So we'll say else set player state for jump. Current player state equals player state dot jump. Perfect. Okay, I think that's all of our player states. So let's go ahead and save the file and return to Unity. Let it compile. And then go ahead and click on our player game object. Scroll down in the character controller script here. And we have a player renderer and player animator reference that we need to make before we hit play. So make sure that you've expanded the player game object's children, and you can click and drag this player animator game object onto each of these slots. Because if you recall, if we select player animator, it has a sprite renderer component and an animator component. So by dragging that game object over, Unity automatically assumes and can see that it has a player renderer and animator component and makes that association. All right, let's finally hit play and see what happens. Okay, so you'll now notice that our mouse is changing animations when I run, when I jump, when I double jump. Perfect. But you'll notice that things are still a little weird. When I run to the right, things look all right, but when I run left, my player is still facing to the right. The mouse is not the correct direction. And when I wall slide, it looks wonky as well. So we're just about there. We just have a few more little issues to clean up. So let's go ahead and move on to the next video. So we just about are finished adding our animation, but if you recall in the previous video, we were having an issue where the mouse was not facing the correct direction that we were moving, and also on the wall sliding, it didn't look correct either. So there's just a tiny bit more of code that we need to add. So pull your script editor back up, and in the character controller 2D script, scroll down to our new method that we added a little while ago, the handle player animation. And we just need to add some new code here at the top where we can check for which direction the character is moving, what velocity he has, and then we can flip our mouse sprite renderer so that he's facing the correct direction. So let's add a comment, and we will say determine which direction our sprite renderer should be facing. So we'll say if rb.velocity.x is less than 0.0, then we wanted it to be facing left. And naturally, by default, the mouse is facing to the right. So we're going to reference our player renderer, and it has a property called .flipx, and we'll set it to true because we want it to face left. And then otherwise, we use an else if here rather than else, so that the player maintains the direction he was last moving. So we'll say else if rb.velocity.x is greater than 0.0f, then we'll make sure that player renderer.flipx is equal to false. So in this comment that I added, is specifically here because if we just had an if and an else, then anytime the player goes to idle and has no velocity, it would flip it back to false. But we just want to say if the input is greater than 0, so that they have a positive velocity on x, then we want to not flip the x, and the mouse will naturally face to the right, which is what we were wanting. So that takes care of the direction that the mouse faces as we move. And then the one other issue was the wall sliding. We actually need to handle the flip X on that as well, because it's kind of opposite. So we'll say if wall sliding, our flip X is handled opposite. So we'll say if is wall sliding, then we can check if wall dir equals 1. So if we're touching a right facing wall, then we'll say player renderer dot flip x equals true. And then else if wall dir equals -1, so a left facing wall, then we'll say player renderer dot flip x equals false. Okay, oops, accidentally jumped up. Go ahead and save this file and return to Unity. And then one other thing I'm going to do quickly that I forgot to do is I'm going to increase my jump velocity from 10 to 20, just because this is a larger scaled level and I want the mouse to be able to jump higher. Okay, so now I can move around, and you'll see now that the sprite renderer is being flipped correctly, so the mouse is headed the direction that I'm running. And then also, when I jump and I wall slide, my mouse is now facing the correct opposite of the wall. And same thing if we come and slide on this left wall. So this is really awesome. We finally have our animations in. It's all working correctly. So we've got our idle, we've got our running, and you can dash and the mouse will move faster. We've got our jump and our double jump where the mouse curls up into a ball. You can jump and wall slide and jump in towards the wall or jump out from the wall. So all of our game mechanics are implemented and we have animations to go with them. So I'm really excited to finally be at this point and for you guys to have a fully functioning 2D character controller along with animations. So I hope that this has really helped you learn and feel more confident that you can write your own character controller and that it can have cool game mechanics and that this can be a base to build upon that you can add other cool game mechanics to. And as far as for this section, you can see how much adding these animations has done. It really makes the player come alive rather than just having a capsule moving around. You have this character that's animating and it really makes the game come alive already. So awesome work, and I'm glad we're finally here.